All right, hello science department colleagues. This will be our training for the science department lab. Oh, there we go. Oh, that's the bell. Okay. This will be the training for science department lab chemical hygiene and safety plan for 2020-2021. I didn't know for sure if we were going to even have chemical safety like trainings this year. We didn't hear anything about it in the first semester, and I wrote to the people downtown, and they said no, we're waiting to decide. We have to hear from down what's going on. In fact, they're not even working downtown. Nobody, it's all empty down there. They're all doing it from home anyway. But I guess I got notified somewhere February or March. Yes, we are going to do it. We want you to do the trainings, and just after coming back and getting in, and it's been just so busy. So we're able to do them through the video and stuff too. And so anyway, I just want to go over what is needed for the science department. There's a giant long PowerPoint that they provide for us to go through, and you can go through all the pages of that. I'll point out a few little things in there, but I want to kind of just focus it more on, since we have new science labs for chemistry, like what chemistry teachers can be doing as far as like storing chemicals and disposing. That applies to everybody, mainly for biology and for chemistry. Physics, there's not a whole lot of chemistry we do in there. I did silicon, like I use the silicon sulfates. We did that with what was it? To make the little, is that right? To make the little bouncy balls. I did that in my physics class before, a long time back. But other than that, there's no chemicals that I really use in there. So, all right. So first of all, here are a few things. OHS Downtown, Office of Environmental Health and Safety, they will send people out to the schools to inspect. As you know, they're not going to do it this year because they're not even working there. But they come randomly. Usually they come once a year. This is not that when they come to check for the inventory. That'll be a different thing. But they'll come and they'll just maybe just do a drop by and walk in and look in any stock rooms. They might do it early in the morning or after school when no one's here. Just walk in and look and see if things are look organized or cleaned up and all that. So the main stuff that they count off for is this, though. It can be, when I say the word organized, it's more like, are the chemicals safely organized? It's okay if you've got a bunch of stuff in there and it doesn't look too beautiful. I don't want to do that. I know how that room got next to me before. But it became a big storage room and a dumping room for a lot of stuff. But anyway, here we go. The top violations were, first of all, they said the number one most common violation is that chemicals were not stored correctly. Incompatible chemicals were next to each other. Secondly, broken containers or rusted containers. Third, they had unapproved chemicals. There's a list of unapproved chemicals, and if there were some chemicals that you want to use to do a demo, you can get permission to do that, or small amounts. But certainly for the unapproved chemicals, don't be having your kids all playing around with them in class and everything. But anyway, number 5, putting chemicals in the fume hoods or on the floor. They should only be in the fume hoods if you want to do a lab there. These are really good, these fume hoods that we have now too. They said shelves and cabinets did not have a restraint system. Well, now, again, in our new rooms, we have a cabinet, they close, all the cabinets close, and they have locks. That's another story. The locks aren't quite working, but they do lock and they close. So that means if there was an earthquake, the chemicals would just hit the door there. They wouldn't fall over all the place and break and spill and all that. So that's good that we have that here. Storage cabinets must, cabinet storage areas. Oh, the chemicals that were in cabinet storage areas were not labeled. Okay, sometimes they have unlabeled chemicals. That is something that we can remove, and I'll get to that later on too. Okay. It said, make sure that aisles are clear, that you can walk through and get around to everything in there easily. Not having a spill kit. I have a spill kit here. Now, they gave us some spill kits like maybe 8 years ago, and we put one around all the old stock rooms. It looks like do I have it in there? I could grab it. Well, it's like a white barrel plastic container, if you see it like a real big plastic container, I'll just say that, like about bigger than a trash can, a little bit bigger than a trash can. See if you have any of those around. You might have them collecting dust and not know what they are, but that's a spill kit. And then the last one was saying that there was an eye wash station. Okay, they didn't have an eye wash stations in places. So those are the biggest violations right there. Now, what I do is once a month, I go around and just look at all the stock rooms to see that it makes that these things are good and cleared off the best that we can with our facilities that we have. And everything's okay right now. I only did one check. I might do one more before the end of the year just to walk around and look at them. Now, as far as chemical pickup, because people were asking me about that, and I went around and spoke to a lot of people. Right now, we're all in the process. We have a lot of chemicals in the old stock rooms that we got to move over into the new stock rooms. Now, some stuff will probably be thrown away, but I won't say thrown away, be removed by downtown. But I don't see it happening before the end of this year. Now, I've been still trying to move equipment and things from my old room into here, and I've started on chemicals. I might show you a little bit my cabinet, how I've started a little bit of the cabinet. But if things need to be removed, the best thing to do is to label them, and you know that they need to have on them, label the chemical, label for pickup. I'll just say that. They can just stay on your shelf for right now until maybe next year when I can go through and we can look at how much. Make sure you put the type of container, like is it glass, metal, whatever, the amount, and for the amount of material, and Darren you saw that there was a Google document in there, we can type this stuff in. The amount, you can just tell me, like, just say, oh, it's a metal, a glass jar, and like it might say on there, calcium chloride or something. That might say that there's like 500 grams. So you can just say, if it's full, looks pretty full, put 500 grams. Or if not, if it's halfway, just 250 or just whatever. You can just make up some number. You don't have to have it perfect. Or if it's almost empty. Even if it's empty with some dust on it, you want them to come get the glass. You don't want to just throw that glass container into the trash for a lot of chemicals. You don't want to do that. The type and the amount. And those are the name of the, obviously the name of the chemical you have. Now for unknown stuff, you can put unknown, and I'll have to come look at the unknowns, and we'll look at that later. But I'll have to do something to figure that out, identify it. But what you can do is a list has to be made, and it has to be faxed downtown. The plant manager has to help with that as well. It has to all be done. It's a lot of work. But a year and a half ago, or whenever it was, I can't remember, I did one of these before last year, before the closure, and we had like 2 carts of stuff that we had in the science room over there, and it was all taken. Finally, they did come and take it during the last year and a half because I saw they're gone. But it's a lot of stuff to get out, and there's going to be a whole lot to get out of the room that we've got. The stock room between 233 and 234, where I used to be, Mr. Blesser, that probably about half those chemicals I want, but the other half I don't want, especially all the liquids and solutions and everything, and so it's going to be a task. And Mr. Nunez mentioned maybe we'll find out if it's possible that we might be able to take them and then see about downtown if they can come, like a special situation, just come to that room and just get all that stuff out. But we'll find out how that works. Okay, now, so anyway, the pickups, they can be done anytime. I could do them anytime, but I usually do them near the end of the semesters. And like the thing is that right now, if we want to have a good amount of stuff on there when they do it. We don't want to just come for 2 or 3 things, but you can do that as well. For biology, you might want to when you're doing dissection specimens and things like that. If you've got it, then you want it to be removed. They can come. You can tell them, and we'll fax it in. They can come pretty quick to get that done. I know Mr. Siegel used to do that before he retired. He would just do it on his own. I think he would work one and fill a form out for that, and then we would just sign off for whoever did it, whoever was doing the chemical safety at that time. Let me check here. A few other things to tell you. All right, let me see if I can tell you some more fun. I don't know, fun stuff about this or not. in the hygiene plan, I put the whole PDF up there for you to look. I know you got this bar in front of me. I gotta get an Allen thing to move it around, but I know this is all I can do right now. This room, I'll show you how it looks in a minute, perhaps. But let's see. Oh, make sure. Yeah, I already told you fume hoods should not be used for storage. The chemical hygiene safety plan, you can look through those. It's a plan regarding policies, procedures to enable lab safety for LAUSD employees. I know you love seeing, like, oh, this thing's actually, my little stand is coming down there. Okay, that's part of the problem there. My back. Okay. It talks about the health hazards associated. Most of the information you'd find on the safety data sheet, STS. Now, in the school training that I also did this week, or you'll see that that's on there as well. There's a good website. Let me see if I can find it. I know I don't have the sds.chemicalsafety.com, sds.chemicalsafety.com, and you can just type in a chemical and search and look at the SDS. It will tell you everything you know about that chemical. Can you throw it in the trash? Will it explode? Well, all that kind of stuff. Okay, page 3 of the PowerPoint talks about hazard recognition, classification, proper labeling, and disposal. So I want to talk about like storing the chemicals and disposing them in a moment. Disposal I talked a little bit about. Well, no, I didn't talk about that. I talked about how we would pick them up. Some important things to know that you know this probably already. We don't have to worry about it this year, but never give your keys out to students. Like say, oh, here, go get this out of the stock room. They shouldn't ever be in the stock room at all. And in fact, that's one thing they want the doors always closed to your stock room. Now, the new building, the doors close. You can't keep them open. The stockroom doors, they automatically close. So that you don't have to worry about that. If they were to come during a classroom and do an inspection and just a walkthrough, if they saw the door open, they'll write that off. They'll say they had the door open. We want to, they'll come back even for that. So we might make a second visit because we saw the lab room door was open. So they don't want the doors open. Let me see. If you ever have waste, like batteries or anything like that, you can put them in a box and label it. Let me know, and I will also do that. Like I usually will get a cart, and I've got some space in the newer stock room where I can put on a cart some stuff on there, like I did before, and like just say if it's batteries or whatever, I can keep it there, and then when it's time to call them to come, like get halfway full or whatever, I can call and get them to come pick up everything on that cart. Make sure, just a few little small notes, make sure that you don't have any air fresheners in the chemistry room or in the lab rooms or in the bio rooms for that matter. If there are any refrigerators, it should be only for food or only for the lab science, and label it that way. Don't have food together next to chemicals. On shelves, once we had that, there was some, they wrote down that there was some chocolate syrup on a shelf right next to potassium permanganate, in the stock room. Don't do that, okay? If things are stored on top of anything, like on the top of a cabinet, make sure that there's a border or something. I'm starting to fall down again, I guess. Or is it coming down? Yeah, I guess it is. I'll have to keep adjusting this. Most of my video lessons that I did them with my chalkboard at home. I'm not getting used to this new setup so much. I haven't been doing a whole lot this way, but okay. Make sure there's a border to keep things from falling down. Page 6 talks about training, inspections. It talks about how the chemical pickups are done. That pickup that was done about a year and a half ago, there were 2 carts of stuff, and that was the first pickup we had in 5 years. So I'm glad they came and got that. We'll get more done. Hopefully we'll get on track next year. After moving all these things over, it'll be nice. Hopefully everything's gonna be straightened up in the next semester or 2. So get it all finished out. But try to get all the stuff moved to your new stock room, obviously. Let me check what else. I just had a few little notes in there. I just thought that in the PowerPoint that page 3, page 6, 5, 6, and 7 just had some stuff to kind of look at, to read on there. But okay, here's a couple things I want to say more specifically for the new chemistry, but it can be also for everybody. Actually, everyone, anybody that has chemicals, you should do this. All right. When you arrange the chemicals in your cabinets, you can't just put them all together. They have to be separated by compatibility groups. Now, I'll put a list on here. This is one that I found from Flynn. And what you can do, the ideal world, the ideal situation would be that you have a group of chemicals. If they match group number, there's 10 groups inorganic and there are 9 organic groups. But in the best case scenario, the chemicals will be on their own devoted shelf, okay, in these groups. Now, that won't be practical for a lot of people because you might not have that many, like I saw in the biology. I mean, they might maybe have just 2 shelves of chemicals total. But what you can do, you might have to spread them over, like, say, 3 shelves. If you have 2 full shells, you might have to spread them over 3 shelves and then just separate a little bit of space between them. Like maybe put a can. Just say if you had a set of chemicals here, they were all in the same compatibility group. Maybe skip about a little bit more than a bottle of space, and then put the other group there. Okay, and that is okay. It is acceptable to do that, to have them where they can't be in close contact with one another. But anyway, here's how it goes. I'll just read off a few of these things. I have a list, and I'll have it on there for you on the. I don't have, I'm not using whatever the screen sharing thing. But the most ideal, as I said, would be by reactivity groups. So I would put them in alphabetical order, and I still got to get that done. Now that'll be for the main stock room. I have some in the classroom that I use for common labs. But anyway, like for example, put say acetates are all in one group. These are all group number 2 inorganic. But acetates, bromides, chlorides, iodide. Hopefully there's no fluoride. You shouldn't have any fluorides at all. Calcium fluoride, you shouldn't have anything fluoride. If it is, let me know. That chemical can stop a heartbeat. That's pretty bad stuff. Okay, oxalates, phosphate, sulfate, sulfite, thiosulfate. The reason why I read through all those are all in one group. And those are probably most of what we have. In fact, I think that most of what we have are inorganic 2, inorganic 4s, and these inorganic 6. That's probably most of the chemicals that we have and use for labs. So a lot of these groups you don't even have. So that also tells it also lets you know, wow, as it falls down again, that you want to it also tells you that that you want to put, it's goofy to label the shelf, all my ones for 10 shelves. It's goofy to label out 10 shelves and have them all there because you don't even have these chemicals. So you might put the ones that are more frequently used closer to the bottom, more reachable, like I said, like 2, 4, and 5 inorganics. And you probably don't have hardly any organic ones at all. Maybe in bio they do have a good bit of organics though. But you still don't have a lot of the stuff that's on this list, I believe. Okay, so anyway, that's the idea of the groups. You can look on the suggested cabinet arrangements. And like I said, you don't have to do it that way. I'll show you here. I'll show you really quickly on my room. All right, and by the way, this is the fume hood. So this is a great deal to boot. You need to use that when you are diluting chemicals or if you're doing any labs that mix those. All right. So this is a mess in here right now. It's just, you can see I've got all these boxes and everything. But I put some chemicals up here. All of these are group 2s, 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 2s. Almost all this is 2s. Then I've got the 4s over here. So you can see how I did that. And I'm going to, just to have them by their groups. Here's their organics up here. See, I put organics and I put group 1, which are metals, there. I mean, sugar and copper aren't gonna mix up with each other. So I just put a space there in between them. So I don't know if that's exciting to see all that or not. I'll try to go quick. I know that y'all don't want to have to sit through this thing so much longer. But there's a few more things I really want to bring up. Okay. Okay, here we go. All right. Disposal. Oh, hold on. I wrote down these things too. It says, things that are easier to access. You might want to put the more common chemicals down there. Acids. Oh, yeah, big deal. Acids that are concentrated have to be stored in an acid cabinet in your stock room. Okay, if they're concentrated, do not put them in the room any concentrated, because you know that a concentrated acid releases gas into the container above it. So, like, for example, if you have a bottle and it says, concentrated HCl, above that liquid, there is HCl gas. It's right there. So as soon as you open that thing up, you do not want to breathe in HCl. It is not a fun experience. Okay, I can tell you, I had a bit of that long time back, and boy, it gave me a horrible headache, bad. And I did that even with in the vacuum area in my lab room, and it's still just a little bit got out. You just got to watch out. I guess maybe I just wasn't thinking. I try to even be careful about that. When you open the container, fumes are going to come out. So you want to be in the fume hood when you do that. You want to have it in the fume hood, or we have the little vacuum pieces that aren't as good in the old rooms. That's where I got the little whiff of that stuff. But anyway, so any concentrated acids, obviously keep them in the acid cabinet. But do not put HNO3. Do not put HNO3 next to these other acids, because what happens is, even though these are closed up, some gas will get out. And HNO3 will also let some gas get out, and you can have some reactions go on. So it should be in a separate area. We have in the acid cabinet, like, just say there are different shelves. It's okay for HNO3 to be on this shelf, and if you want to really be good about it, you can even put a little zip bag around it where the bottle. And you probably don't need much. We used to have a lot in the other building, but only a small amount. I just do some demos with it. There's not really anything, only an AP. I only do one lab with that in AP, and it's a demo for other people. So I don't really need much of that at all. Okay, all right. The other thing is, let me see. Acids, acid cabinet. Oh, bases. Bases cannot be in the acid cabinet. Bases have to have their own cabinet, and there's not one in there, but like, for example, sodium hydroxide, potassium hydroxide, ammonium hydroxide. In fact, that's a really great one, because, ammonia fumes can come out of ammonium hydroxide. HCl fumes can come out, and then that's a lab demo. That's a cool lab demo, but you don't want it to happen, unplanned in your lab area. So bases should have their own dedicated cabinet. I was looking at those and thinking, I don't have as many bases, so maybe I'll put them in the smaller cabinet right there, the one that says for the volatiles. Okay, now what else is there to say? Again, if you're ever going to even do a dilute, if you want to dilute down acids or bases, do it in the fume hood as well. And remember, always add acid to the water when you dilute. Don't put water into an acid, but add acid to the water. Do what you oughter, add acid to the water. That's the little phrase. Okay. Now, what I do, as far as, let's say when you do an experiment and you need to dispose of the chemicals from that experiment. Okay. I think I've gotten pretty good about this. That most of the labs that I do for my classes, for general chemistry at least, they can be thrown out or down or in the trash, or they can be diluted in the drain. It'd be okay. Okay? But what you should always do is check the safety data sheet to find out. Now, for some examples of this, I'll tell you. Obviously, you know that sodium chloride and sodium iodide, chlorides and iodide, those are in table salt. Okay? And iodized table salt. So the general rule is, if it's in food or in an over-the-counter medication, you're probably okay. You're probably going to be fine to either throw it in the trash or into the sink. So sodium chloride, sodium iodide is okay. Magnesium, when I do the magnesium lab, the white powder that you produce there is the active ingredient in milk of magnesia. So there's no problem with that, just throwing it into the trash. You can just throw the metals. Throwing metals in the trash is fine. It's not going to be. I mean, you might want to keep them, and I use them as much as I can till they're no good, or you can recycle the metals as well. But the metals will be okay. I mean, you're like a small little strip of or a piece of magnesium, but hopefully you've already reacted it and you won't need it. So it should be completely reacted. What else? Certainly they won't ever be playing with any of the alkali metals, sodium, potassium, and all that, obviously. Or not calcium metal either, but those metals, no. But every other metal, you're okay with. Okay, what did I write down? Vinegar, obviously, acetic acid, that's okay. Just as well as HCl is okay too, hydrochloric acid. The only thing is make sure that you dilute them. If they're stronger than regular, just, food vinegar, then make sure that they're diluted before you put them into the sink. But usually if you do the experiment correctly, HCl is going to be used up anyway, and so it's going to be like chloride, so like sodium chloride left over. Let me see, HCl, sodium hydroxide is found in Drano, and it's also in lye soap. That one's okay. But again, diluted. Potassium hydroxide is okay too. Calcium carbonate, sodium bicarbonate, potassium carbonate. Carbonates are safe. Calcium carbonate is like in Tums. When you eat Tums, like stomach acid. And of course, they just produce carbon dioxide. So you're okay with that. And what else? Okay, copper 2 sulfate. Now, this is one that you don't want to just pour down the sink. Okay, copper 2 sulfate. What I do the hydrate lab with that. And when you make when you prepare anhydrous copper 2 sulfate, you can actually reuse it. So I do that. I tell the kids, don't throw it out, and I collect all of it into a container. Now, be very careful about the dust. You don't want to inhale that dust, and I tell them the same, to be very careful not to inhale the dust around or like shake it around or anything. And some of the sulfates are okay to throw into the trash. You should check the SDS, but you don't want to put them in the sink. But what I do, copper 2 sulfate, I just reuse that. Now, if you want to do a lab and just say if you have some copper sulfate solution left over, if you really had it left over, I would use it for demos and other things later on, just keep it stored. But if you wanted it removed, if you had kids prepare copper 2 sulfate solution and they didn't react it all the way down to anything, then label it and put it, like, close it off in a jar, and we could have them to come pick it up the way they would come pick biology specimens. And that is about it. So I hope that this will help a little bit. Thanks for bearing through all of this. I know if we've been in person when I've done these things, I'll like go through and I'll try to do it real quick in 10, 15 minutes. I guess I went a little bit longer because I have the video thing here going on, but oh well. All right. Well, thank you very much. Just sign the little forms and all that. I'll see you guys later on.